start or wait for a few more minutes because only 34, 37, 36. 36 are there. Okay, so how many of you have gone through the file? I have uploaded there in document section, a file section or in folders, reading material. Avilas Mukherjee.
Yes, sir.
Want to say something because you raised hand?
Sir, you asked, na, how many of you?
Okay, I'm expecting some reply rather than just putting.
Okay. Yes, sir.
No problem. So you have gone through that because I want to get connected rather than just seeing your raised hand. No problem. So I hope that you have gone through, right? And schedule I have given, we have total 13 experiments. And the first one is scheduled as measurement of infiltration rate by using double ring infiltrometer. Is it clear?
Yes.
So let me show you a little bit more because today I taught you infiltration. So moreover, it is clear how to measure. What is infiltration? That is very much clear. That's entry of water into the soil from the surface. Just entry. Yeah, anybody want to say something? No. Okay, so can you see my slides?
Yes, sir.
Okay.
Yes, sir.
So it's a first experiment. It is scheduled for the day. Measurement of infiltration rate by using double ring infiltrometer. As you already know that single cylinder infiltrometer, what is our target? We are simply trying to find out what is infiltration rate to the soil. And that's why first it was started by using single cylinder and second it was double cylinder. Mostly who have attended the class in the morning theory, it was very clear. What is the purpose? Basically, idea is the whole field is getting infiltration water or experiencing infiltration of water, right? And that's why we want to just learn what is the rate of entry. That's why first it was started by using single ring and second it was double ring. So why double ring? Because it has more precision, it is better, it gives better information about basic infiltration rate of the soil. That's why it has been used. So we have to experiment this to understand this by using this experiment or by using this instrument in the field, that what is the rate of intake of soil as infiltration. So our experiment title is, or simply say objective is, measurement of infiltration rate by using double ring infiltrometer. So what we are using here, 2 meter cylinders, 30 centimeter and 60 centimeter in dia, hammer to drive these cylinders inside the soil up to a certain depth, wooden plank to put on the cylinder, or basically here you will see it's an iron plate basically on the top of these two cylinders, so that once we are hammering this, both of the cylinders are getting inserted in the soil simultaneously at the same time, sorry. So hammer, hook gauge to measure the depth of water, and bucket and graduated charge to measure the water amount. And for time you can have a stopwatch or you can use your mobile stopwatch, whatever. So these are the information basically our instruments we need to go for this experiment. So I have given you the slide, means file, and if you have gone through, it is very clear that what is infiltration. That is basically If you have gone through that file, it is very clear about the theory of this experiment. Infiltration is entry of water from the surface into the soil. Simply movement of water. Any question? Somebody want to know anything? Okay, so movement of water from the surface into the soil is simply called the infiltration. The important aspect is here. The infiltration rate decreases and nearly becomes constant. That develops after some time has elapsed, means after some time it becomes a constant rate of entry of water into the soil from the starting of irrigation or starting of supply of water to the field or to the plot, and that is basically called the basic infiltration rate or final infiltration rate, or simply we are telling infiltration rate. So there are two terms, instantaneous infiltration rate and final or basic infiltration rate, or say simple words, infiltration rate. So you have learned what are different factors which are affecting infiltration. We can measure it by using single ring or double ring infiltrometer. So we are here today to use double ring infiltrometer to measure the infiltration. And these two rings are of 30 centimeter and 60 centimeter diameter. So once we are inserting these two rings inside the soil, it is standard. We are inserting near about 10 to 12 centimeter inside the soil. Just like in the morning single cylinder, in theory it was near about 50 centimeter. In double cylinder, we are inserting this, means cylinders inside the soil. Suppose this is the top. So it is soil here. So inside the soil it is 10 to 15 centimeter only. And it is maintained on the top because it's a 30 centimeter. So 15 centimeter near about it's at the top. So we are maintaining water here in both the cylinders near about 10 to 15 centimeter somewhere, or 10 to 12 centimeter itself. Basically the outer ring, I will show you, is to prevent the lateral movement of water from the inner cylinder. So we are simply targeting that from the inner cylinder, it's vertical movement of water only. It is not going towards any lateral condition. So cumulative infiltration is the total quantity of water that enters into the soil into a given period of time that we are measuring basically. So to find out the infiltration rate, that is IA, we are simply measuring the total depth of water that entered into the soil in a particular time, that is delta T. And if we are dividing that depth of water that infiltered or entered into the soil by that delta T, we are getting simply the infiltration rate or average infiltration rate. So this is the field arrangement simply. Double ring or double cylinder infiltrometer. You can see different shape and size, but both are concentric, or there are two concentric cylinders. Inner is 30 centimeter in dia, outer is 60 centimeter dia, and inserted in the soil 10 to 12 centimeter and filled near about 10 to 12 centimeter of water. In filling, it's most important, if you have gone through the methodology, I have given the file there, it is written, we are first filling this inner cylinder. And remember, when we are filling this inner cylinder first, we need to take utmost care to not disturb the natural soil condition here. So what we are doing, we are putting some barrier that controls direct heating of pouring water on the ground surface. So we are putting, say, a plastic sheet, a small plastic sheet, or some mulch, or maybe a little bit sand, so that it is not creating, but generally sand is not used because it works like a sealer later on. So it's better to use some fibrous material or a plastic sheet first put on this, means ground surface of the inner cylinder, and pour the water once water is filled up to a certain depth, it is removed and then outer cylinder is filled. Reason being, outer cylinder is to control the lateral movement of water from the bottom of the inner cylinder. So we are filling this first and this later so that it is taking care about the lateral movement outside here, but it is not permitting any lateral movement from the inner cylinder. So this is arrangement and this is the methodology. You have already gone through what I suppose, because I have submitted you the file. So I simply assume that you have gone through what is the depth of entry, means insertion of cylinders, how to do that, what much amount of water should be poured in cylinder, inner cylinder first, outer cylinder second, and finally we are observing it, means observations. So simply for how many minutes, what it was water that has infiltrated. So before filling means starting of the observation, and this is the ending of observation. We are recording the depth of water that entered into the soil in this elapsed time t. So t1, t2, t3 and so on. We are observing, and every time after each observation we are filling back to that certain height that we are maintaining in inner cylinder. So always we are trying to maintain the same amount of head of water inside the inner cylinder so that there is no effect of head. So once means we are starting, we are filling up to the level and we are simply observing what is the depth of water that has entered. So we are simply finding out what is the depth that has infiltrated. We know the time and we can find out average rate of infiltration, means this is the depth in time t. So if we are dividing d by delta t or t, it is simply average rate we are getting. And then we are cumulating time 2 minutes, 4 minutes, 6 minutes from the beginning, and same way it is cumulative infiltration in beginning, suppose 1 millimeter, 2 millimeter, then 5 millimeter and so on. So we are getting two information, average rate of infiltration and cumulative depth of water that infiltrated into the soil, and we are trying to make the relationship. So once we have these observations, I have yet to start, and Wednesday I will discuss about the estimation of infiltration. So if we are fitting such kind of observation in equations, or say empirical equations are developed, there are 4 empirical equations what I was introducing today, but I get into detail on Wednesday class. So here 2 equations what I am suppose that you will fit into this observation are like here, Kostyakov equation. Kostyakov in 1932 gave a relationship between infiltration rate and elapsed time t. So what is infiltration rate? That was empirical equation Kostyakov has developed. So infiltration rate is equal to k times t to the power minus n, where n varies from 0 to 1. That is soil property, and k is constant for soil characteristics. So it depends any number, and that is basically based on the fitting condition of observed infiltration to a time t. So you can find out from the data you have observed here, say for 150 minutes or almost 2.5 hours and so on, for different time intervals. Initially we are starting for 2 minutes, then maybe 4 minutes, then 6 minutes, then 10 minutes, then 15, 20, 30, 40, maybe like this, and finally 150 minutes suppose we are observing for 2.5 hours. We are getting what is the rate of infiltration. It will be high rate of infiltration initially, but here it will tend to become the constant. Now these observations you can fit into this equation. So you know the infiltration rate for different time k t to the power minus n. So you can find out the value of k and n here for this particular condition. So observations, our infiltration rate we are measuring are using in this equation in centimeter per hour. Time is used basically in hour, or you can convert everything in minute. So this is the first target, to fit your observations into Kostyakov equation. Then second equation we have United States Soil Conservation Service Department developed an empirical equation in 1964 to represent the total amount of water that infiltrated into the soil. And this Y is basically accumulated or cumulative infiltration in centimeters. That is in elapsed time T, that may be in minutes. So to find out infiltration rate from this equation, if we are differentiating this equation Y, or accumulated infiltration, with respect to T, so dy by dt, if we are making this or developing, infiltration rate will be developed, and that could be A alpha t to the power alpha minus 1. And this constant will become 0, B. So in this way, we can fit your observations, or you can fit your observations to this equation and find out the value of A, alpha, and B as well for using cumulative equation. So these are the constant condition or constant for this equation, and values of A, alpha, and B varies from 0 to 1. So you have observations, you have field setup of double ring infiltrometer, you have observations for 140 or 150 minutes. You need to calculate what is the average infiltration rate, what is the cumulative infiltration depth of water with respect to time here, with respect to time here. You need to fit these observations in these two equations, find out the value of K and N in Kostyakov equation, and in US SCS 1964 equation, the value of A, alpha, and B by using these observations. And finally, you need to prepare your results in the form to find out what is the average infiltration rate of this soil. For different observation, you can average out with respect to time, weighted average, time weighted average you can find out, or simple average you can put. So what is the average infiltration rate of this soil? And you need to plot the graph between average infiltration rate versus time and cumulative infiltration rate versus time in the single graph, single. And let me tell you or make you very clear that you need to use graph sheet. You cannot use, or you should not use, the Excel sheet. You will be submitting your record handwritten by using graph sheet, plot the graph. It means in a standard manner. Put the scale, what scale you have followed to plot these two, and these two conditions should be in a single graph, single figure. So average infiltration characteristics, infiltration versus time, infiltration rate versus time, accumulative or cumulative infiltration versus time, and third, fitting Kostyakov and US SCS empirical equation to your observation to find out the value of K and alpha, A, alpha, and T, K and N in Kostyakov, and A, alpha, and T in US SCS empirical equation. So this is our objective. These are few precautions. Those are already given in my file. I have put there. So you can read it and find out the condition. And finally, once you are finished, handwritten, graph made, arrange everything in PDF form and submit to Mr. Uday or Mr. Rajesh Ranjan. So all BTech students and all students who are registered or missed earlier, and now they are registered in this semester to Mr. Uday. So BTech plus any previous batch student. Here, Mr. Rajesh Ranjan will take care about all dual degree student who wears roll number starting from 3, or I think it is starting from 3, AG something, or 19 AG 300 or something, AP or whatever AF that is. So that exactly half students are there in these two category or these two conditions. So you submit your cards to Mr. Rudan or Mr. Rajesh. Now, how this you can work once you are in the field, because you are not in the field, so I have prepared one video to show you how really this is worked or this is done in the field condition. So what I am doing, I am putting a file in file video in the class material, uploading there. One video I am uploading, just give me 1 minute. I guess it will not take much time. Can you see there is one file, experiment 1 infiltration underscore DR double ring. MP4 file is there. Can you please see, everybody? And let me know whether this is available. Or I can share you my.
Yes, sir, we got it.
Yes,
You
sir.
got it?
Yes, sir.
So everybody, can you please watch this file? Because this is, let me open this in my computer first. Yes. This is near about 15 minutes, 14.58 minutes. It's somewhere in between. It's a repetitive matter. So can you please watch for 15 minutes and then let me know whether you understood or you have any query to ask about this experiment? Can you?
Yes, sir. Yes.
Okay. So you can access this video. Can you? You have access to this video?
Yes, sir.
Okay. So please watch
Yes,
this
sir.
video for 15 minutes and we will meet after 15 minutes, means 2:15. It is, sorry, 2:55 it is. So 3:15 we will meet again. So I will give you the observations then. If anybody has problem or facing problem in downloading or running this video, please let me know. Let me ask from one person at least. Sitaram? Mr. Sitaram.
Yes, sir.
Your video is running?
Yes, sir.
Okay. Okay. Then watch it. I am here. And let me know once you finish it.
Okay, sir.
So now, this is double cylinder infiltrometer method to measure the infiltration of soil in natural field condition. So we have two cylinders of 30 centimeter length. Let me show you the length. More than 30 centimeter here we have. So this is outer cylinder. Then we have inner cylinder that we need to put in the soil in concentric form. Then we have one lid to press both the cylinders at the same time up to a desired depth, that is near about 10 to 12 centimeters, by using the hammer. Then we need to pour the water inside the cylinders. First we are putting the water in the inside cylinder, inner cylinder. Then we need to put the mechanism to measure the depth of water for every time. So we can use either a scale, that is very rough method, once we do not have any other method. Usually in this method a hook gauge is used, because for water contact condition, if we are measuring the depth, hook gauge is the most precise gauge to measure the level of water. However, we have two, this is indigenous, we made here floating type scale. We have arrangement, some means our lab developed arrangement here, or we can put a scale as well. So let us start first by marking the depth of insertion of these cylinders in the soil up to 10 to 12 centimeters. So let us mark first the depth of cylinder we need to insert inside the soil. This is more than 30 centimeters. So let us take exactly 12 centimeter depth of insertion of this cylinder. It will go inside the soil, 12 centimeter. Outer cylinder as well as at the same time inner cylinder, 12 centimeter here. Though we are not going to see this inner cylinder insertion, but let us mark this. So let us put this cylinder in concentric manner without disturbing soil. We have inner cylinder exactly at the center. Let me check whether it is in center. Let me check whether this is in center. Near about 15 centimeters every side it should be. Just like here it is 14.5, 15. This side it is third, so it's not concentric. Now it's near about concentric condition here. So let us fix this here. Put this lid cover so that both the cylinders are going at the same time to the same depth. So let us do it. Okay, so now let us see that cylinder is inserted up to near about 12 centimeter inside the soil, both the cylinders. You can see from there and here as well, we can see inner cylinder is also inserted up to near about 10 centimeter here, 12 centimeter, sorry. Now we need to maintain the head of water. We need to put first inside cylinder water and then outer side. However, if we are pouring water directly, it will seal the top surface of soil, that is the natural condition. So we can put in that, means to control the sealing of top surface, either jute fibers, sand, or any material which is restricting direct pouring of water on the soil. So here we have polythene sheet. Let us put first here so that soil is not disturbed inside the cylinder, means inner cylinder. So let us pour water first inside the cylinder. Before pouring water, let us put the scale. As I told, hook gauge is the most required scale here. However, we do not have, so we can put this floating type scale arrangement here to measure the depth of water that is infiltered in inner cylinder. Or we can as well put some scale. Let us have the cross check by putting a scale as well here at the support, so that we can check the water depth that is infiltrating with time. We can have some support here, just for support, another scale we have, so we can put here. Now pour the water first in the inner cylinder, so that any infiltration starts from inner cylinder, and that improves or controls the errors which is we are generally getting by using single cylinder infiltrometer measurements. So we are putting water first inside inner cylinder and then outer cylinder. We can and fill it by putting hand so that coil is least disturbed or not disturbed, and then in outer side we can put by any means, anyway it is not getting affected, so we can fill this water in outer cylinder. Okay, once it is filled up to 10 centimeter, then we will start observations. So let us fill first with 10 centimeter and fill it by putting hand so that coil is least disturbed or not disturbed, and then in outer side we can put by any means, anyway it is not getting affected, so we can fill this water in outer cylinder. Okay, once it is filled up to 10 centimeter, then we will start observations. So let us fill first with 10 centimeter. That we pour water near about same level in inner as well as in outer cylinder, and we need to check, just like I told, near about 10 to 12 centimeter water. If you just see, it is fixed because it's a little bit inserted inside. It is near about 12 centimeter of water that is coming inside cylinder. So we can start our observation, and you can see just like here as well, this is floating type, so this is also giving a level, means precisely the moment water goes down it will go just like less automatically, and once we are putting water it will come back again, so it is giving precise level of water inside the cylinder. And after every observations, initially we will start for 2 minutes, then again 2 minutes, then next 5 minutes, 2 times, second times 5 minutes, then 10 minutes, 2 times 10 minutes, and then we can increase up to say 1 hour or 1.5 hours, so that we can find out, we can achieve the constant rate of infiltration when soil is quite saturated up to this level, or the zones up to which we are thinking about. So let us start observation first for 2 minutes. So this is the time. Let me put here my time, and this is stopwatch I am using just for 2 minutes. Let us go start from here. 2 minutes. So what is initial level you can have here? It is, how much is it? It is 5.3. 5.3. Yeah, it's near about exactly precisely 5.3.
Yeah, yeah.
You can see it's 1 minute past. We can zoom. We can zoom it. Water is moving fast here. So we are near about 5.8 and time is near about 1 minute 20 seconds. Done. 5.9.
So 1 minute 52 seconds. So let us focus. Exactly 6. You can see exactly 6 and 2 minutes we have here. 2 minutes 2 seconds, but a stopping time to it. So it's a 6. We started from 5.3 and now it is 6. So near about 0.7 centimeter of water infiltrated in just 2 minutes. So let us fill it again up to the level we started. 5.3. See, the scale is coming up. Yeah, it is. Let us start this time from 5.5.
It's 5.3.
5.3. It is 5.3. Okay, it is 5.3 again. Let us start from 5.3 and time for 2 minutes again. Let us observe. Okay. Let us observe for 2 minutes. Okay. 45 seconds. It is moving. How much is this?
5.5.
5.5. Almost 1 minute. Okay. So 1.5 minute, 40 seconds. Okay, so from started it's 1 minute 30 seconds. Let us wait 30 seconds more. So be ready. Okay. Just 10 seconds from where we started. Wait. Now just see 5.7. 5.7. It is near about in 2 minutes. 0.4 centimeter or 4 millimeter, 4 to 5 millimeter. So in this way we need to record next for 5 minutes 2 observations, then 10 minutes 2 observations, and so on. So we will send you the observations for infiltration in different time period, and then until water reaches to a certain depth of entry of water from the surface inside the soil, that is infiltration, and that becomes constant. Then you need to calculate the other conditions: infiltration, cumulative infiltration, infiltration rate, and you need to fit two infiltration equations based on this observation you are getting. That's all. Thank you.
Of K will be determined by like after finding N only, right?
By fitting the equation.
After getting the N only, we can determine the like unit
Yes.
of K, right?
K is unitless because it's an empirical equation. So it's only representing the soil characteristics, compactness, sandy type of soil, or something. Basically, it's a soil characteristics. Types of soil are governed by N value. Sandy soil, clay soil, like that. So if you are plotting the data for different types of soil, it will give you different values of K.
Okay.
Excuse me, sir.
Yeah.
So can you please explain that point? Like, why are we using two rings? Like, why is it more precise now like in the presence of the outer ring?
I didn't get your question. Means it is not clear to me. Can you please repeat your?
Sure. Sir, in the morning you taught us like we used only one ring, right? But now here we are using two rings because it is more precise. So what is the reason for?
Okay, let me share my presentation once again. Just wait a minute. Okay. I'm sharing presentation. Okay, the question is, you are asking, let me take one blank sheet here. Why we are using double ring rather than single ring, right? Is that question?
Yes, sir.
Okay. So if we are using a single ring, what is our purpose? This is soil surface, right? And suppose, imagine that this whole field is getting or receiving rainfall everywhere. It has, means say in this way, a kind of plot you can imagine here. It is a rainfall characteristic, means it is rainfall. So everywhere it is infiltrating or not? Everywhere, every point. Yes or no?
Yes, sir.
Okay. So our simple question is, since from every point of this field, this may be a simple plot or maybe a big area like basin or whatever it is, everywhere water is infiltrating into the soil, means entering from the surface to the soil, everywhere, every point. So if we are putting a single cylinder, suppose here, somewhere here, I cannot make a straight line because of computer, right? So it is in the morning, you might have seen it is 50 centimeter ring, right? Question was, somebody asked in the morning itself, we can have a very small ring like this and it can as well measure, yes or no?
Yes, sir.
Okay, so the moment it is entering water, it will immediately reach to the boundary of this cylinder, and the moment it is reaching to the boundary, it will move laterally, yes or no? But
Yes.
when we are considering a big area, big field, our target is everywhere it is going vertical, but it is experiment we are doing in a small place, very small, just like 30 centimeter diameter area. And sure, we need to make sure that water is not moving laterally. But in single cylinder, if we are taking a smaller depth, inserting inside the soil, immediately it will move laterally. That is wrong concept of infiltration. Water should move vertical. It should not give a higher rate of flow the moment it is reaching to the bottom of the cylinder. That's why we are taking a long cylinder of 50 centimeter. But there is a chance the moment front is reaching to the bottom, it will certainly move to the lateral side as well. So rate of entry of water, which is supposed to be same everywhere, when it is uniformly distributed water in this field will change here. And that's why we have the next idea of putting two concentric cylinders inside the soil. Here it is soil, and of lesser depth, sorry, this will be this hole, lesser depth of, here it is one cylinder and it is another cylinder. So it is just how much? 10 to 15 centimeter inserted and 10 to 15 centimeter, suppose it is at the top. So once we are filling this, this inner cylinder is still vertically receiving water or sending water, but this outer cylinder is taking care to move any water here in lateral direction. Reason being, it is itself at the same time getting water. So from here, at the outest of this outer cylinder may move outside, but not from the inner cylinder. And that's why we have reduced the depth of cylinder inserted into the soil from 50 to 10 or maximum say 15 centimeter to get sufficient time. Did you get my point? And that's why we are using double cylinder to make sure that infiltration characteristics, means entry of water into the soil from this big area, exactly or accurately we are getting this information.
Yes, sir, it's perfectly clear.
Did you get the point? Answer
Yes.
for your question is clear?
Yes, sir, yes, sir.
Okay. Any other query? Any other query, anybody? No query? Just say no if you don't have any means confusion or any query.
Sir, can you show that slide, the 9th slide?
Which slide?
9th one, sir.
9th one. What is specific in that? Can you see this slide?
Yes, sir. So here average infiltration rate is
This in
it
Costico
will be
equation.
time average.
Right here?
No, sir. Next.
Next slide. Here. Okay. Results. You can see the slide or not first?
Yes, sir. I could.
Okay. Okay.
So my doubt
Average.
is,
Yeah.
like to calculate average infiltration rate, like we will be time it will be a time average of infiltration, or like
Okay.
how we will calculate.
Yeah. Okay. This is average infiltration rate. Suppose elapsed time is here 2 minutes. Right? Here again means in series you are going 4 minutes. So what is elapsed time from here to here? Again it's 2 minutes, right? If it is now 10 minutes, what is elapsed time from here to here? 6 minutes. Is not that? And suppose you got a value of here infiltration depth of say 1 centimeter. 1 centimeter. Here it is 0.8 centimeter. For an example I am taking, and here it is for in 6 minutes. Suppose it's 1.2 centimeter. Is that clear to you?
Yes, sir.
Now we are taking average infiltration rate in centimeter per hour. So it is going in 2 minutes 1 centimeter. So what about in 60 minutes? 1 into 60 divided by 2, that is simply in 30 centimeter per hour, right? So this is infiltration rate. In the same way, it is again 0.8 in 2 minutes. It's in 6 minutes 1.2. So you can calculate what is the rate of infiltration, that is in centimeter per hour. Now the question is to find out accumulated infiltration or cumulative infiltration, that is 1, 1.8, it is 3.0 and so on. That is in centimeter, remember. And this rate is in centimeter per hour. So now there is no need of averaging because this is the standard rate now centimeter per hour. So what is average? Average is here. Average of all these, that is simple average of infiltration rate. Initially it was high and then it becomes a constant value. You can find out quite good representative condition of average rate of infiltration into the soil. Is it clear, your query?
Yes, sir.
Okay. Any other question? Anybody? So let me assume that you are very clear about the experiment. And now I have updated experimental observations. Let me show you here experimental observations I have given there in the folder that you have already seen. In your files, there is one Word file, experiment 1, field observations, infiltration. Let me show you as well. Share my desktop, where it is. It is. So these are the field observations of double tube infiltrometer experiment. So it's what we have observed for 180 minutes. So this is before filling, before starting, and this is starting of your experiment. So idea is, if you have seen in this video, there is one floating type of depth measurement. The moment water is infiltrating, it is going below. So next will be somewhere here. So scale here will go down. So initially it is suppose 6, slowly it will get down. So it is 5.3, means beginning at 5.3, once it is going down it is 6. So simple idea is getting difference of these two observations in this elapsed time to find out the depth of entry of water. So this file I have shared, you can take the observations from the files and complete your learning on this particular experiment of determining or measuring the field based double infiltrometer ring used in filtration characteristics of soil. Is it clear?
Yes, sir.
Okay. Any query if you have? Further query, question? If you couldn't understand at any point, you can ask me here.
Sir, how are we going to find the values of K and N in the equation?
Fitting the curve. You have learned R, Python, MATLAB, or any software. There I am giving you freedom to use the software. By least square method is basically used, but that is not supposed to be done here by using pen, calculator and other things. But you can use any of the software to fit these values of infiltration rate, cumulative infiltration. Finally, you are calculating with elapsed time to fit these two equations, Kostyakov and SCS 1964 equation, to find out the value of K and N and A, alpha and B. Is that clear?
Okay, sir.
Okay. So use any software and give the little bit basics in your writing, that how you have fitted these values to find out finally the value of K and N and A, alpha and beta. Is it clear now?
Yes, sir.
Okay. Any other query? So observations are there. I have put this file in your file folder, class material folder, sorry. So there are 3, means experiment, then video, as well as observations are available. So please complete this experiment by Saturday 5 o'clock and submit to respective TA. Is that clear?
Yes, sir.
Very nice.
Yes, sir.
Any other query or question if you have, you can ask. Otherwise, you are free to complete this lab experiment by Saturday. Okay?
Yes, sir.
Okay. So I'm taking the attendance now. Okay. Then you are free from my side today.
Thank you, sir.
Okay.
Thank you,
Welcome.
sir.
Welcome. Welcome.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
ठीक है राजेश।